Hi, all of my YouTube viewers. It's Crystal Hill. I'm making a new video. I'm having to do it with a free online screen recorder. And the reason why is because the screen recorder on my computer isn't working. And as a result of that, I'm having to use a free online screen recorder to do it because I'm not monetized. And so I don't get any money for the videos that I make. So what I'm doing is I'm doing A/B testing. So A/B testing is carried out when you want to test a control sample and an experimental sample. And basically what I did was I watched a YouTube video about A/B testing, and so it's a method for evaluating changes or improvements for developing services. So it's common in many fields. So I watched the video, and the video at the end, they had some A/B testing in Python. But what happened was the screen was really blurry, so I couldn't see it. So I went on the internet and I looked for some A/B testing myself, and so I'm just found some code, and then I modified the code for what I wanted it to do. So that's what we're going to be doing. The first thing I wanted to do is okay. So there's three ways that you can do A/B testing. And the way that you can do A/B testing is for the t-test, which is for small samples, and the z-test, which is for larger samples, and then chi-square. So I did the t-test and the z-test, but I couldn't do the chi-square. I tried my best. I do have a sample of the chi-square. And basically, this particular exercise, what I found, it was with the t-test, but really it should have just been the z-test, because the t-test is for a small sample and the z-test is for a large sample. And since this is a large sample of 1,000, then I think it should have been a z-test, but I'm using the t-test and the z-test just to give you an idea of it. So the first thing we're going to do is we're going to import our libraries. We're going to import NumPy as NP, which creates NumPy arrays and performs numerical computations. We're going to import pandas as PD, which creates data frames and processes data. We're going to import random, which makes our random number generators. From collections, import counter. We're going to count a list, what's in a list. From scipy.stats, import t-test.end. So this is where we're going to do the t-test. And from statsmodels.stats.waitstats, import z-test as z-test. So we're going to do the z-test. And import SNS, Seaborn as SNS, which enables us to visualize the data. So we're going to create control and experimental groups. So variation A is going to be save money today. Variation B is going to be 10% off now, because an A/B test is you're testing a control sample and an experimental sample. So you're testing two samples. So since we're testing two samples, we have to have two samples. So what we're going to do is we're going to assign the users randomly. So we create a function that's going to assign the users. So you're going to have a random generator, and if it's less than prob A, it's going to be A, else it's going to be B. And then so now we're going to use the function in some code. Users equals assign user 0.5 for I in range 1000. So I printed the user, so it's going to be either A or B. And then I printed the count. So A is 514 and B is 486. So theoretically, A would have been the winner even though this is all randomly generated, let's say if you gave this test, gave these phrases to 1,000 people and asked them to decide which one they liked best, well, 514 would say they liked A, and 486 would say they liked B. So that means that A would have been the winner. So now we're going to carry out the A/B test. And so this is all going to be done with random numbers because, so log equals random.random, log1 equals random.random. You print log1 and print log. So log is 0.8 and log1 is 0.06. And then control A or CTR equals np.random normal, log equals log, scale equals 1, size equals 1000, CTRB equals np.random.normal, log equals log 1, scale equals 1, size equals 1000. And so we got the means of CTRA and CTRB. I use Seaborn to plot a histogram of CTRA and CTRB just so you can see what it looks like. And then now we're going to use a t-test to analyze the results. T-stat p-value equals t-test.n CTRA CTRB. Print your p-value, it's 9.84. If p-value is less than 1, print the difference is statistically significant. Else print the difference is not statistically significant. And so this is 9.84 to the negative 55. The difference is statistically significant. If p-value is less than 0.1, and it could be, you can make it a 0.05, but I was having some issues with this program, so I made it 0.1 just to make it easier for the computer to pick up the p-value. If NP mean CTRB is greater than NP mean CTRA, print variation B is the winner. If NP mean CTRA is greater than NP mean CTRB, print variation A is the winner. Else, print no winner found. And so in this instance, we had variation A being the winner. So now we're going to analyze it on a z-test. So ST, comma p-value equals z-test, CTRA, comma CTRB, print the p-value, which is 4.25 to the negative 58. If p-value is less than 0.1, print the difference is statistically significant. Else, print the difference is not statistically significant. And so it's less than 0.01, so the difference is statistically significant. If p-value is less than 0.01, if NP mean CTRB is greater than NP mean CTRA, print variation B is the winner. If NP mean CTRA is greater than NP mean CTRB, print variation A is the winner. Else, print no winner found. So we get variation A is the winner. So that was it. And that was whenever we did our hypothetical, when we assigned our random values, we had A as the winner when we assigned our random values, but that does not necessarily always have to happen. We were just lucky that it happened in this instance. But so another thing that we did was we performed the chi-square test. I could not get the chi-square test to work on CTRA and CTRB. I tried really hard, and chi-square is one of the tests that you should be able to use to do A/B testing, but I was not able to get it to do work. But I did actually get some code here so you can use the chi-square test. So from Skippy.stats, import chi-square contingency, info equals 100, 200, 300, 400, comma, that's your first sample, 50, 60, 70, 80, that's your second sample. Then you print your info so you can see what your info is. And stat.pvalue.dof equals chi-square contingency info. And then it's supposed to be the first three values. So I had to do brackets, colon, 3 brackets. You print your degree of freedom, which is 3. Significant level equals 0.05, or it could be 0.1 if you want that. It depends on what you want your significant level to be. Print p-value, so we got a p-value of 0.0001. If p-value is less than or equal to significant level, print reject null hypothesis, else print accept null hypothesis. So since it's less than 0.05, we reject the null hypothesis. And that's just an example of how to do the A/B testing with chi-square test, although I wasn't able to get it to work with CTRA and CTRB. So that's it for your A/B testing. I hope you like it, and look forward to making another video for you in the future. If you like my video, please like, subscribe, and share. And thank you for watching my video.